Hello and welcome. Let's solve another question on the trapezoidal load. Alright, but in this video, we'll be using the formula that we derived from our first video to solve this. We have derived equations for reaction at the support of this trapezoidal load, and then we have derived equation for our shear force and equation for our bending moment. So we'll be using that to solve this question. And if you can recall, we said that the reaction at the support A, this R subscript A, is nothing but what? It's nothing but 2W1 plus W2 multiplied by L all over what? All over 6. All right. So this will be equals to, and our W1 is what? 400. So it's going to be 2 into 400 plus what? Plus W2, which is what? 800. Then we multiply by L. Our L is the length, which is 5. Then divide by what? By 6. So if you do this, 2 multiplied by 400 is 800. 800 plus 800 is 1,600. 1,600 multiplied by 5 divided by 6. We are going to have 1,333.33 kilonewton. All right. So the reaction at the support B, the reaction at support B is equals to, for you to easily recall that, just bring these two to this side, then you are done. So I'm going to have W1 plus 2W2 multiplied by what? L all over what? 6. So this will be equals to, I'm going to have 400 plus 2 into 800. And if you close the bracket, you multiply by 5. Everything divided by 6. So if you do this, what are you going to get? 400 plus 2 into 800. That is 2,000 multiplied by 5 divided by 6. That is 1,666.67. So this will be equals to 1,666.67 kilonewton. All right. So for us to continue now, the next thing we are going to be doing here is we are going to start with our shear force equation. If you can recall, shear force equation. All right, so from our shear force equation, the equation we derive from for our shear force is what? Is that shear force equation is equals to what? Is equals to reaction at A minus half into what? Into W1 plus WS multiplied by what? By S. All right, but if you look carefully, we know what our reaction at A is, we know what our W1 is, but we don't know the value for our what? WS. But if you can recall again, we derive an expression for our WS, which is nothing but what? W1 plus what? W2 minus W1 all over L multiplied by what? X. So we said that our W subscript S is equals to what? Is equals to W1 plus W2 minus W1 multiplied by S, everything divided by what? L. All right. So that's what we have. Now, the next thing is we are going to substitute for W1 and W2 and S. So we said our W1 is what? 400 plus this one is 800 minus 400 multiplied by what? S divided by what? 5. All right. So if we do this, we are going to have WS to be equals to 400 plus what? 800 minus 400. That is what? That is 400. And 400 multiplied by S is 400. 400 divided by 5. That is going to give us what? 80. So we are going to have what is here to be what? 80S. All right. So we are going to replace WS here with what? 400 plus what? 80S. So we are going to have our shear force equation now to be written as what? It's going to be RA, but our RA, what is the value for our RA? 1333.33 minus half into what? Into W1. Our W1 is what? 400 plus what? Plus 400, then plus what? 80S multiplied by what? By S. All right. So this will be equals to 1333.333 minus, now 400 plus 400 is what? 800. multiplied by s is 800s. Then if you divide that by minus half, you are going to have minus 400s. All right. Then if you do this, minus half multiplied by 80s, that is minus 40. If you minus 40s multiplied by what? S, you are going to have minus 40s squared. All right. So this is our shear force equation. All right. So now we are going to be using this shear force equation now to get the shear force at each point. So at S equals to 0, because if you section this trapezoidal load, you section this at this point. So we call this W subscript S. So from the distance from here to here is what? S, right? So this is where we come about our WS. We have already done all of this stuff in our first video. So I encourage you to watch that if you haven't. So to get more understanding on this, I'm not just doing magic. All right. So now we derive that from our our WS is equals to what? This. All right. So we want to find the shear force at point what? At point A. All right. For us to do that, this our S now is going to be, at point A here, S is equals to what? 0. There's no value at this point. There's no value for S. So S is going to be equals to 0. So I'm going to say at S equals to 0, it means that this shear force equation is going to be what? The shear force at point what? A will be equals to, so it's going to be 1333.3 minus 400 into 0 minus 400 into, minus 40 into what? 0 squared. So 0 multiplied by 400 is 0. This will be 0. So the only answer will be left, that will be left here is 1333.33 kilonewton. So this at S equals to 0, the shear force at point A is what? 133.33. All right. So now for us to get the shear force at point B, it means our S will be equals to what? The entire length. At S equals to 5 now. So at S equals to 5, at S equals to 5, it means the shear force at point B will be equals to 1333.33 minus 400 into what? Into 5 minus 40 into 5 all square. So if you do this carefully well, you are going to have 166. This is going to give us 1666.67 kilonewton. All right. So that is what we are going to have. All right. So now we are done with the shear force at point A and at point B. All right. Now the next thing you are going to be doing is this. We know that any point that our shear force is equals to 0, we are going to be having our what? Maximum bending what? Moment. So if we equate this shear force equation to be equals to 0, we are definitely going to get the value of S, which our shear force equation is equals to what? 0. So we are going to be using that value of S to get the what? The maximum bending moment. All right. So now we are going to equate this equation to be equals to 0. So when this equation is equals to 0, so we can therefore rewrite this equation that is here. So it's going to be 0 equals to 1333.33 minus what? Minus 400s minus 40s square. All right. So if you rearrange this, I'm going to have 40s square minus 400s, plus 400s minus 1333.33 equals to what? 0. All right. So we know that this is a what? A quadratic equation, right? So now we can now use a quadratic formula. So we know that from the quadratic formula, S is equals to minus B plus or minus the square root of what? B squared minus 4AC all over what? All over 2A. So S will be equals to, our B here is the coefficient of what? S. So it's going to be minus 400 plus or minus the square root of 400 square minus 4 multiplied by A. A is what? 40. Then multiplied by minus 1 minus 1333.33. All right. So if you do this, then you divide by 2a. A is what? 40. So 40 multiplied by 2 is what? 80. All right. So our S here will be equals to minus 400 plus or minus. All right. If you press this value in your calculator, that is 400 squared minus 4 multiplied by 40 multiplied by minus 1333, and you take the square root, you are going to get that to be nothing but what? 611.0097. 611.0097 all over what? All over 80. All right. So our value for S here will be equals to S will be equals to minus 400 plus 611.0097 divided by what? Divided by 80. I'm not going to be considering the second value, because it's going to be minus 400 minus 611 minus 0. If you take minus 400 minus 611, that is 1011.0097. And if you divide by 80, you are not going to have a positive answer. You are going to have a negative answer. And if you look at this, our given being, we don't have any negative length here. So it means we are not going to consider the negative value. We only need a positive value. So the only value that will give us a positive value is what we have here. And if you press this, minus 400 plus 611.097, if you divide that by 80, you are going to have nothing but what? 2.64. So it means that our S is equals to 2.64. All right, so we have gotten the value for S. Now, the next thing we are going to be calculating is our what? Maximum bending moment. Our bending moment. So let's write bending moment equation. Bending moment equation. All right. So if you have carefully observed, if you have carefully done your shear force equation well, your bending moment equation is pretty simple. So you just need to come back to where we have our shear force equation. So our maximum bending moment will be equals to, our bending moment equation will be equals to this 1333 that is here is the reaction at our support what? A. All right. So now if you section this beam at this side like this, so and we have our arrow A here. If you take our moment towards this side, it's going to be arrow A multiplied by what? Multiplied by S. So it means we are going to multiply what we have here by S for us to get what? The moment at that point. So we are going to have this to be 1333.33 S. All right. Then we have minus 400 what? S. All right. Now if you look at this again, we have here to be what? 400, right? Now, you know, here we have a what? A uniform distributed load and a what? A uniform varying load. Look at this. I've already explained all of this stuff in our first video. All right, look at this. So we have a uniform distributed load, which is what? 400 kilonewton per meter. All right, so if you want to convert this to a point load, it's going to be what? 400 times what? The distance that it covers. So it's going to be 400 multiplied by S, which is what? 400 S, right? Then it's going to cover what? It's going to act at the what? At the center of this line. That is going to be at what? X over 2 to this side and X over 2 to this side. So if you take your moment, anyhow you are taking your moment, it's going to be 400 S multiplied by what? X over 2. So it means here we are going to multiply what we have here by what? X over 2. So we are going to have minus 400, that is S squared, all over what? All over 2. Then similarly with what we have here, we are going to multiply this by X all over 3, because this is a what? Uniform varying load. So I'm going to have 40, then to the power of S cubed all over what? All over 3. So that's what we are going to have. All right. So this will be our what? This will be our bending moment equation. All right. So we can rewrite this, because we know that 2 can go in 400, which is going to be what? 200, right? So we can write this as what? Bending moment equation to be equals to 1333.33 S minus 200 S squared minus 40 s cubed all over what? All over 3. All right. So now I'm going to be cleaning this side so that we are going to get our bending moment, or we can get the bending moment at what? A here. It's not hard. So let's do that first. Now, let's start with the bending moment at point A. So at s is equals to 0 again. At s is equals to 0, we are going to get the bending moment at A. So at s equals to 0, the bending moment at point A will be equals to 0 as well. Why? Because we have s here all through. S multiplied by everything that is here is going to be what? 0, right? All right, so we are going to do the rest here. At s equals to 0, we have gotten our bending moment at point A. So now we are going to consider at s equals to 5. So we are going to get our bending moment at point B. So it means that at s equals to 5, I'm going to have bending moment at point B, which is going to be equals to, so it means we are going to substitute 5 for this bending moment equation. So it's going to be 1333.33 into 5, then minus 200 into 5 square, then minus 400 into 5 cubed all over 3. So if you do this, you are going to have 0 as well. So that's what you are going to have. And there are some times that, due to the approximation, you understand that you might have done from the beginning of this. If you do this, you might get something like 0.0 something. Do you understand? That is due to the approximated value. So for the purpose of exam, I would just advise us to write the direct answer, or the answer that you are getting from your calculator directly, so that you will not miss any step. Do you understand? Because I have tried some question like this, that when I got to this, I'll substitute. Like this one, try substituting 5 here, you might get 0.0 something. Do you understand? But see, if you already know the concept in your head, you should know that the answer here is supposed to be what? 0. All right. So now, the next thing we are going to do here is, now we want to get the maximum bending moment. Why? Because we already have the value of s, where our what? Our shear force equation is equals to what? 0, which is what? 2.64. So I'm going to substitute 2.64 for s in the what? In the bending moment equation. So we are going to have maximum bending moment, which is going to be equals to 1333.33 into what? Into 2.64, then minus 200 into 5 square, sorry, into 2.4 squared, to 2. Sorry, don't know why I'm writing small. 2.4 squared minus 4t into 2.4 cubed all over what? 3. All right. So if you press this in your calculator, you're going to have 1863.672. 1863 point what? 672.672. Then this will be in kilonewton meter. All right. So these are all the required values that we need to draw our shear force and the bending moment diagram. So we can draw our bending moment diagram now. All right, so for us to do that, we are going to be drawing at each point that from the support down. Right. All right. So here again. All right. So now the next thing we are going to do is to draw our reference line for our shear force. All right. All right. So now let's draw the shear force diagram first. Now, for us to do that, know that the shear force at point A is 1333.33, which is a positive value. So that is going to be at this point here. Let's put that here. So it's going to be 133.33. All right. So now, and the shear force at point B is what? The shear force at point B is sorry, if you press this value, you are going to have a negative answer. It's going to be equals to minus 1666.67. That is what you are going to get, please. All right, so here we are going to have a negative answer here, which is probably going to be somewhere around here. So let's put it here, minus 1666.67. All right. So now we are going to draw the shear force diagram now. So now don't forget, we said our shear force diagram is equals to 0 at what? 2.64. So adibin it is on a graph. I am going to come here since the total length is 5. So it means from this point our 2.64 should be somewhere around here. Exactly. You can just put it here because this is just a hand sketch. Exactly. So adibin it is a graph. You trace at 2.64 here, then you put your curve, then you draw. Exactly. All right. So now let's take out this curve. All right. So we are going to have something like this. All right. So that is what we are going to have. So let's just take this point to be our what? From this point to this point to be our 2.64. All right. So we can therefore trace this down, but it is too much. Let me just try. Rewrite this here. All right. So this is minus 1666.67. All right. So the reason why it is curved, I hope you know, because it is a trapezoidal load, and it consists of what? A uniform distributed load and a what? And a uniform bearing load. And when you are representing that on your shear force, is going to be a curve. You understand? Straight down. So that this is what it looks like. All right. So now let's draw the bending moment diagram now. Let's draw the bending moment diagram. So let's take this down. All right. So now you observe that the bending moment at point A is what? 0. The bending moment at point B is also 0. All right. But our maximum bending moment, if you trace it from this line down, since our shear force diagram is equals to 0 here, so if you trace this point down, all right. So it is, if you trace this point down, then we said our maximum bending moment is what? 1863, since it is a positive value. So let's just take something, the point to be here, 1863.672. All right. So we are going to draw a curve from this point to join this point, and a curve to join this point. Then that will be our what? Maximum, that will be our bending moment diagram. So let's just take this. Yeah. So just manage it. It's just a hand sketch. All right. So I'll sketch this. All right. All right. So this is positive. Why this is what? Negative. All right. So yeah, this is positive all true. All right. So let's sketch. All right. So that's it. So this is the shear force diagram and the bending moment diagram for this question. So stay tuned we are still going to do another derivation on this when it is facing in this direction. So that's what we are going to do next. Thanks.